This is Jo from Maths Tutor Me. Today we're doing coordinates and graphs, and we're going to be graphing linear relationships. So we're going straight into our examples today because these are practical questions we're doing. So our first question says, a shop sells packets of highlighters. Each packet contains 5 highlighters. Let X be the number of packets and let Y be the number of highlighters. Complete the table of values. Okay, so if X represents the number of packets of highlighters, if I have one packet of highlighters, then that means I will have 5 highlighters. If I have 2 packets of highlighters, I will have 2 lots of 5, which means I'll have 10 highlighters. 3 packets of highlighters, you think of it, 5 plus 5 plus 5 means I have 15 highlighters. 4 packets, I'm going to have 20. So if you look at this, so there's a pattern coming here. Each time I'm adding on 5 or I'm multiplying the number of packets to get the number of highlighters by 5. So 4 times 5 gives me 20. So 5 times 5 is going to give me 25. And 6 times 5 means that there'll be 30 highlighters. For B, it says use the grid over here to draw and label the linear relationship. So this is my axes that I've drawn up here ahead of time. The one going across the bottom is going to be my x-axis, which, remember, represents the number of packets. Okay, and this axis will be the y-axis, which represents the number of highlighters. Okay, so looking at our x values, I start at number 1, I have 2, 3, 4, 5, up to 6. So I could fit those having one number on each of those there. 1, 2, 3, 4, 5, and 6. Now, the y-axis, I start at 5 and I go up to 30. So I don't think I have 30 spaces there. Perhaps I could go up by 5s on my axes here. So that would be 5, 10, 15, 20, 25, 30. Okay, that fits. All right, so let's plot some points now. When x is equal to 1, y is equal to 5. So I come across here to 1 and I go up to 5. When x is 2, y is 10. When x is 3, y is 15. 3 up to 15. 4 goes to 20. 5 goes to 25. And 6 is 30. And what you'll see is all those points that I plotted there make a perfect straight line. If you get your ruler, you could draw a line going through all of them like this. And you could even come down to the 0, because if I had 0 packets of highlighters, I would have 0 highlighters. Okay, and that pattern would continue. If I wanted to keep going, I could have 10 packets and I could extend my graph out to find out how many highlighters that would be. So that's the graph complete. Question C, describe in words the relationship between the number of packets and the number of highlighters. So we worked out while we're doing our table over here that the number, so I should say the number of highlighters is 5 times the number of packets. Okay. D, write the relationship as a rule using x and y. So if the number of highlighters is 5 times the number of packets, remember that X is the number of packets. If I multiply that by 5, that is equal to the number of highlighters, which we call Y. So that means we could write that as the equation, Y is equal to 5X. Okay, so that's the end of my example today. Okay, so here is a question for you to have a try of. Just warning you, it's probably a little bit trickier than the one I've just shown you. These questions take a little bit of time and a bit of space. I'm only doing a few examples today. So you can pause the video and give this question a go and then restart to see the answer. So this question says, a school has rectangular tables that can sit 2 people on each long edge and 1 person on each short edge. So a rectangular table like this, you can sit 2 people on the long edges like that. So the crosses represent people sitting there, and you can only sit 1 person on each short edge. So that would be how you could sit people around the table. But in A here it says, if 2 tables are placed so that the long edges are together, how many people can be seated? If the long edges are together, that would mean that I would have, let's turn the rectangle sideways, 1 person there, 1 person there, and I can fit 2 people here. But if I join up another table right next to it, again, I can have 1 person there, 1 person there, and 2 people here. But I've lost the 2 people that are there. Okay, so let's see how many people can sit around these tables now. 1, 2, 3, 4, 5, 6, 7, 8. 8 people can sit around the 2 tables when the long edges are together. Okay, let's have a look at what B says. If X stands for the number of tables and Y stands for the number of people that can be seated, complete the table below. So if we had 1 table, that was what we drew up here, we can have 1, 2, 3, 4, 5, 6 people sitting around that table. If I add the second table on, I'm only actually getting 2 extra seats, and I now have 8 people. So what do you think is going to happen for a third table? If I was to join a third table onto here, this has only gone up by 2, so I'm going to go up by 2 again. That means that there'll be 10 people able to sit around there. For 4, it's add 2 on again. We'll have 12 people. For 5, add 2 again. 14 people will be able to sit around those 5 tables if we follow that pattern. Part C, we want to plot the graph on the grid provided over here. Okay, so across the bottom is going to be our x-axis, which represents the number of tables. Okay, the vertical axis is the y-axis, which represents the number of people that we can sit around them. Now, for our x-axis, we have numbers from 1 to 5, so we have enough space that we can put 1 on each line and still have room to spare. And the y-axis, we have to get up to 14. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, we don't quite have enough room, so we'll have to go up by 2s. 2, 4, 6, 8, 10, 12, 14. All right, so 1 table can fit 6 people around it. 2 tables can fit 8 people. 3 tables can fit 10 people. 4 can fit 12. And 5 can fit 14. All right, so that makes a nice line there. and we can join that together. And the pattern would continue this way. However, we wouldn't ever really be able to have people sitting around 0 tables, so we won't continue that down to 0. All right, so that's our graph complete. Describe the relationship between tables and people. For every table that we added across here, the number of people that could sit down increased by 2. So that's what we need to write down here. For each table that is added, the number of people that can sit down increases by 2. All right, that's it for our lesson today. Keep practicing and join me again next time. Bye.